This is kind of a tricky assignment. We're going to do angles of complex numbers. If I graph this on the real and imaginary axis, it looks like this. It would be over 3, down 4, and here would be my imaginary number. Alright, what we're trying to do is figure out what is the angle of this complex number if I charted it just like this. The angle we're talking about is right here. We could express this angle a lot of different ways. Alright, we could express it in degrees, radians, we could call it a negative angle, we could call it a really big positive angle. Remember, the way we label angles is counterclockwise rotation, right? So this is a positive 90 degrees from there to there. From here all the way over would be positive 180. A rotation in the other direction would be a negative angle. So if I go this way, down to there, that's negative 90. And what you're going to see on these instructions is a way for you to express the angle between a certain two things. I want you to notice it says radians, and might not have seen radians since way back when in geometry. So remember, pi radians is the same thing as 180 degrees. So when they ask us express the angle theta between negative pi and pi, what they're saying is in between negative 180 and 180. So that's the only way we can express these angles. This gets kind of tricky, and I'll explain to you why here in a second. All right. First of all, how would we ever find the measure of this angle? Right. Way back in geometry, we would draw a triangle like this, and we'd say, all right, this is opposite, which is 4. This is adjacent, distance of 3. Opposite over adjacent is the tangent, and we would use the inverse tangent. Now, you don't have to think through that every time because you're going to use that exact same formula on all of these questions. So the proper way to do it with complex numbers, is to always use the inverse tangent. Let me fix this real quick. So we're going to use the inverse tangent of B over A. Remember, B is the imaginary part, A is the real part. So if I'm doing this from the very beginning, I'm going to say, all right, let's find the inverse tangent. I use inverses to find angles of negative 4 over 3. Let's pull up the calculator to do that. All right, so inverse tangent, negative 4 over 3. So 4, negative 4 over 3. Inverse tangent of negative 4 over 3. And you should get on your calculator negative 53.13. So negative 53.13 degrees. Now remember, that's in degrees. All right, our answer is supposed to be in radians. We will convert it here in just a second. I would advise you to always do these questions in degrees, and then we will convert it back later. All right, so negative 53 degrees. Where is that located? All right, let's double check to make sure it's in the right spot. Negative 53 degrees would be from here rotating down, right? If I went all the way down, that'd be negative 90. So it seems like negative 53 is about correct, right? And they want our answer expressed in between negative pi and pi. Okay, we have it in degrees. How do we change it to radians? we start with that, and then we multiply it by this. So, or we can multiply it, or really the faster way, let's say divide by 180, and then times pi. That's the conversion. All right, so if we do that really quick, let's bring up our calculator again. So divide that by 180 times pi, and I end up with negative 0.927. Negative 0.927. It says round to the nearest thousandth. So 927,295. That was the whole thing, round to the nearest thousandth. That's this spot right here. So I'm going to say that's it. Negative 0.927. And that's our angle. You're going to get some funky answers on this assignment. Let's do one more question. There's another thing that arises, and sometimes we'll have to add or subtract maybe some degrees. And I'm not sure you're going to actually see those in this assignment or not. We'll kind of work our way through and we'll figure it out. All right, so here we go. -3 and -8 should be down here somewhere. This time they want us to express it in between -180 and 180. It would seem that the angle should be something in the neighborhood of bigger than 90, but less than, bigger than -90, or smaller, depending on how you want to think about it, and -180. So somewhere in between those two things. That's what seems the answer will be. All right, so we should have an answer something like that. Let's do an inverse tangent. The inverse tangent, not tangent, but inverse tangent of -8 over -3. Let's use our calculator. Inverse tangent, -8 for -3. We end up with 69.44. 69.44395. Yada, yada, yada. Okay, the problem is we just got an answer, which is 69.44395. That's a positive angle. A positive 69 degrees would be somewhere up here. How does that happen? All right, so if you take a look at what we just typed in, we typed in a fraction that is -8 over -3. The calculator simplifies this as being two positive numbers because a negative divided by negative is a positive. The calculator thinks we're trying to find this spot up here. It doesn't know that we want two negatives, right? 3 and 8 would be the exact opposite quadrant all the way across here. So the way that we want to adjust for this is we have to go from 69 degrees all the way down to here, somewhere in between -90 and -180. The way to adjust is to literally rotate that much. So when we rotate that direction, we have to subtract. Sometimes you'll have to do this. That's why every one of these I've been graphing first. 69 degrees doesn't work. It's in the wrong location. We have to subtract a half rotation of a circle, right? Half all the way across. So we should subtract 180. If I subtract 180 from that, I end up with -110.556. It says round these to the nearest tenth. So we're going to call it -110.6. There we go. All right, tough assignment. Get a hold of me if you have questions.